Okay, so just a few notes. Everybody should be paying attention. All right, so this is going to be mass and volume notes to go along with the lab that we're working on. It's the whole point of the lab. Okay. So the success criteria we've been dealing with has been about measuring, not only measuring accurately, so not only being able to look at a graduated cylinder and seeing the right number, like if the water was at 10 milliliters, I'm not looking at a graduated cylinder and saying 30 milliliters. That would be way off. That would be inaccurate. So we got to be accurate. But more importantly, what we were working on that measurement worksheet on the last notes is the correct level of precision based on the instrument we're using. Well, today we're going to move to a new success criteria. And what this is that we can describe, I can describe the relationship between mass and volume. That's the point of this lab. So I want to show you exactly what we're going to be doing here. All right, so write that down. Got that in your notes? Okay, so we're going to try to describe the relationship between mass and volume. I wouldn't be asking that unless there was some kind of relationship between mass and volume. I did move the quiz back to Tuesday, by the way. I want to have more time to review and practice some things. Give you plenty of time with your graphing today and understanding the main concept. So when we do these notes, we're actually going to do them in parts. We're going to write a little bit, and then we're going to do some work on the lab, and then we're going to come back to the notes and write some more. So the thing that we have to do, what we're going to do today, is we have to, first of all, step one, we're going to plot our points. Okay, you guys should know how to plot points by now. Shouldn't be too difficult. And so I'm going to be switching back and forth between your lab worksheet and these notes here, the smartboard notebook. So let's take a look at the worksheet that you're doing. So this is the worksheet. So first thing, and please pay attention. My last class did not pay attention very well, so the basic stuff that I talked about, they didn't even have that done, and a lot of people lost their participation points today. So on here, what are we graphing first of all? Okay, so I want you to graph the mass of water versus the volume of water. So what two numbers are these? Just to clarify, first of all, if we're dealing with the graduated cylinder and we looked at the volume in the graduated cylinder, we wrote that down, okay? We wrote down some number of milliliters. That is the volume we're graphing, okay? So we want to graph that volume. We want to graph this volume. So it's really for each part, it's the first line we did, okay? And I'm just showing 3 of them because it goes off the page, but there's the 4th one. Okay, can't see the 5th one, but we're going to do all 5 volumes, and we're going to do their corresponding mass. Now understand that the first mass that you did, okay, you found the mass of the graduated cylinder, right? Then you did the total mass of the graduated cylinder in water. Okay, that went here. But what I want you to graph is for whatever volume this one is right here, I want you to graph the volume, or sorry, the mass of the water, which is in grams. Not this mass, not this mass. It's the third line. Does everybody get that? Because that's, I mean, I sent them to work on their graphing. 10 minutes later, I walk around to some groups that didn't even know which mass to graph. And I just told them just like I told you. Okay? So it's in each set of data, it's the third line, just the mass of the water. So that's when we took the total mass of the graduated cylinder and water and subtracted the mass of the graduated cylinder, which leaves us with just the mass of the water. Okay, so this is the one we want to graph. Everybody clear on that? Now, by the way, our volume the volume units that we're using when we do our graphing on this side of the lab worksheet, it's in milliliters because we used a graduated cylinder. But when we graph on the back side, it's going to be different because on the back side what we did was we did the plastic cube. So we had to take this length A, this width B, and the height of the water, and we multiply those three things together to get the volume. So this is what we want to graph for the volume with the plastic cube. But this time, it's going to be centimeters times centimeters times centimeters, which means this is going to be in centimeters cubed, cubic centimeters, right? And then we found the total mass of the cube in water, and then we subtracted the mass of the cube, which gives us just the mass of the water, which again, that's the one that we want to graph for mass, okay? Good so far? Okay, so let's talk about what we're doing on the actual graph. We got to have it set up right. I'm going to go back to the graduated cylinder side, so this will be the front side of your worksheet. So here's the graph. And of course, what's the first thing we always want to do? Starts with a T, ends with an E, has idle in the middle. Title. I'm just going to call it mass versus volume. Can you put volume versus mass? Sure. Okay, so you can write that right on your sheet right now. You can put that on the graph. And it's going to be the same for both graphs. Okay, now, as far as the manipulated variable goes and the dependent variable, they're kind of interchangeable in this case. You could say that the volume depends on the mass. You could say the mass depends on the volume. So I'm going to tell you which one to put on which axis. All right? On the y-axis, going up and down, I want you to put mass. And we always have to include our units, which on both sides of the sheet is going to be in grams. Okay, both parts of the lab, we used a balance. We found grams. Maybe you got to use a triple beam balance. All right, so always in grams. On the x-axis, we're going to do the volume. Now the volume, like I pointed out just a second ago, changes depending on how we found volume. So for this side of the sheet, the volume is in milliliters, but on the other side of the sheet, it's going to be in what? Not grams. Cubic centimeters, okay? All right, so if you have all that on your graph on the front side, good to go. You're all set up. Now I'm going to do some stuff on here just to illustrate a concept, but don't do any of this because this is just me playing make-believe just to demonstrate a concept, okay? I am going to number my lines by 2, all right? So 2, 4, 6, 8. Here's 10 milliliters. 12, 14, 16, 18. Here's 20 milliliters. I'm just going by 2s. So this would be 30 milliliters. I'm going to do the same going for mass too. So 2, 4, 6, 8. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8. All right. So don't do that. Don't do that on yours. You got to figure out what you want your scale to look like depending on your numbers. All right, and then I'm going to, like I just said on the notes, plot the points. All right, so let's say I plot the points, and my 5 points are all right here. Okay? So I've plotted the points. All right, back to the notes. Step 2, I'm going to draw a best fit line. We have done this before. Okay? The best fit line, just to make sure we all have a good understanding of this, goes through the middle of the data, but not necessarily a data point. Okay? That was something I identified last hour. Students were confused because when they were trying to make their best fit line go through the middle of their data, they're like, but it doesn't hit one of our points. It doesn't have to hit one of your points. It can hit one of your points, but it doesn't have to. Okay? We just want to kind of look at our data. Where's our data at? What looks like a straight line through it? I wonder if I can do... I don't think I'm going to be able to do that. All right, so... All right, on mine, I kind of look at where the data's at. I would use a yardstick or ruler probably to do this. Okay, oops, I forgot something important. Back to the notes. Question we have to ask. Should best fit line go through the origin? Okay, so what that means is should we make this go through 0, 0? What does 0, 0 represent for this lab? If you had a point at 0, 0, what would that represent? The start? Possibly. What do you think? Anything else? Other ideas, opinions? Let's take a look at it real quick. Here's our graph. So if I had a point right here at the origin, what would that represent? 0, 0. 0 what? 0 what? 0 grams, 0 milliliters. So you're saying if an object has 0 grams, would it make sense that it has 0 milliliters? So if it has no mass, it takes up no space. Not true? How many people think yes, true? Air takes up space. Does air have mass? It doesn't have mass at all? It better, or else we're going to all explode. Air does have mass, yes. It's not very dense compared to our bodies, compared to many other objects. But yes, it does have mass, and yes, it does take up space. The actual definition of matter, it says that has mass and takes up space. Okay, so anything that is matter, anything that is a particle, has mass and takes up space. So therefore, going back to what we said a minute ago, 0, 0 does actually make sense. If something has no mass, takes up no space, makes sense. So the answer to our question on this lab is yes, it should. Okay, so we're going to go through the origin. That's not always the case. When you make a graph, that's what you ask yourself. Look at the x unit and look at the y unit and say, does it make sense that it goes through 0, 0? In this situation, yes, it does, but not all situations. Okay? So the reason why we ask that is when I draw the best fit line, I'm going to start from the origin. Okay? So when I look at my graph here, I am going to start here and try to go through the middle of my data. It's supposed to be a straight line through the middle. Remember, it does not have to hit any of my data points. It's supposed to be a straight line. Okay, pretend that's a straight line. Okay. Looks like it bows down in the middle there a little bit. All right. So what we want to try to do is after we draw our best fit line through the data, again, don't do any of this on your graph because it's all wrong. The next step that we're going to do is we are going to try to calculate the slope. You'll see slope at the end of your worksheet. So the slope basically tells me how steep the line is. It also tells me if it's going up or going down, okay? And I actually did, if you look at the back side of your lab sheet, you'll see that I did actually put in there how to find slope, but we should write it in our notes too. And I might want to describe it a little differently than I did on there. Okay, so what we're going to do is we are going to pick two random points on the best fit line, okay? Not our own data points, two random points on the best fit line. Remember, the best fit line might not run through or hit any of our data points. So basically our graph, the data points, after we draw the best fit line, we're done with them. We can ignore the data points. Well, now we're just looking at that best fit line. Okay, so we're going to pick two random points on the best fit line. Now I like to try to pick like anywhere where it hits like an intersection, and maybe if I had drawn this straighter, it would hit an intersection a little better. What I mean by an intersection is where the grid points come together. So this kind of hits one here. Let's pretend if this was straighter, it would hit here, let's say. Okay? And the reason I pick those is it's just easy to read what the points are. Okay? So there's my two random points I made. Again, I'm going to make them blue so you can tell they are not my data points. I'm done with my data points. I just use those to figure out where the best fit line is. Okay? So this is what we do. The point that's farther to the right, I'm going to title this X2, Y2. And the point that's closer to the origin, if I go along the x-axis, I'm going to call this X1, Y1. Okay? So if I write that into our notes so that we have it for later, I'm going to say point farther to right is X2, Y2. Point farther to left is X1, Y1. So we just picked two random points on the best fit line. So we only have two lines. One is farther to the right and one's farther to the left. One is on the right and one is on the left. Okay, on the best fit line. Cool. All right, so if I go back to my sample graph to try to figure out these numbers, look at my X values, look at my Y values. What do they actually represent on my best fit line? Again, not yours, mine. Good. Okay, so let's look at my numbers and see what happens here. So on mine, So if I'm looking at x1, I'm just looking at the x value. I know, I heard that in your math classes, a lot of times to find slope, you just count the number of spaces or whatever, and the number of marks. Okay, if you do that, that only works if each of the spaces counts as the same amount, or by ones. That will only work. If you have different values, then it won't. So that's why I go with this method, because it'll always work. But my x1, so if I'm looking along the x-axis here, going across here, the first spot comes down and hits at about 16. Okay, so 16. And then for my second one, that hits at like 30. Okay, so those are my x values. This would be x2, and this would be x1. And then I look at the y values, which of course the y values are these guys, right? So if I look at, and this is again why I picked the intersections. Where does the line hit the intersections? It works a lot better. Is if I go across here, then that would represent 2. Okay. That would be my y1. And then over here, this hits at this mark, which is 6. All right. So that's my y2. All right. Okay. Okay, so we're almost done. So this is how we actually calculate the slope. Is what we do is we take y2 and subtract y1, and we're going to divide that number by x2 minus x1. Okay? So on my graph, if I looked at those numbers, so this is just, you might know the difference of y2 minus y1. You might know that as rise, and x2 minus x1 as run. Okay? Maybe that's how you saw them. So from my sample, what these numbers would be, and I want to make sure I include the units too. So from my sample, maybe I should change the color here. So my sample, my y2 was 6. Okay, y2 is 6. And 6, what were the units for the y-axis? Grams, right? Okay, so it's 6 grams minus y1, which is 2 grams. Okay, what does that equal, 6 minus 2? 4. All right, so the top number is 4 grams. And then I'm going to do my run. So x2 is 30 what in this case? Milliliters. Okay, so 30 milliliters. And I'm going to subtract x1, which is 16 milliliters. And so that comes out to what? Anybody know? 14 milliliters. All right, and the last step is just take 4 and divide it by 14. So let's see, I've got a calculator on here somewhere. So 4 divided by 14. 4 divided by 14 equals 0.2857. I'm going to round off at maybe 2 decimal places, 0.29. So when the next digit is 5 or higher, I round up. If the next digit is 4 or less, I keep it where it's at. So I would call this 0.29, 0.29. Okay, so the approximate slope of that line, that best fit line I drew, would be 0.29. And then it's important to write the units. It would actually be 0.29 grams over 1 milliliter. That's what that represents, okay? The bottom's just 1. Any number over 1 is just that number, right? We all understand that? 50 over 1 is just 50. 265 over 1 is just 265. But I want us to see the units. That's why it's important. Okay? So that's what your job is to do on your graphs and to have your plots pointed, your best fit line done, and find your slope and write it down for both graphs. You have 19 minutes to do that in this class. I'm going to stamp those before you leave. So that's your points. If you get it all done, cool. If you don't get it all done, you're losing points. So you can go back to your groups. Please don't touch any of the lab materials there. Don't play with that stuff. It's out because my afternoon classes still need to finish up. Don't touch that stuff, but you got to get this done and bring it to me to get a stamp before you leave today. All right?